and that is Milind, who is a data scientist and developer based in India. He was an early adopter of Fused and is definitely one of the most active members of the Fused community. He's quite creative, designing workflows that make use of the strengths of many tools, including Earth Engine, DuckDB, Xarray, Python visualization libraries, all brought together in Fused. And so for a concrete example, Milind will be talking about a Fused app that he has created that aggregates rainfall.
Thank you so much, Tyler, for the lovely introduction, and I will jump straight to my demo. So yeah, what is the exact problem that I'm solving? The problem that I'm solving is how can I find correlation and similarities between two locations anywhere in the whole world. So like if I wanted to find two similar locations which feel the same, if you wanted to find, if you wanted to relocate from one place to another and wanted to find similar locations which feel the same, twin city is what I've built using Fused. You can find your demographic twin, you can find your location twin, you can find your weather twin. So basically lots of different parameters that you can find twins for. And why would you want to find a twin? So basically there are so many business applications. I have a lot of friends here in this call right now who are into marketing, who are data scientists, and there is something for everyone in geospatial and Fused. So what if you wanted to find your next winning location? What if you wanted to get the big picture of climate? And what if you wanted to perform a site selection for your physical business stores? So this is where you come at. This is my app, and this is the first public demo that I'm showing for Twin City. You get to select a location. So here I've selected a location in San Francisco. So what Fuse does is it's getting the data, past 1 year of data for each month, and it's creating a vector out of it. So everyone who's been following up with LLMs are getting familiar with embeddings and vectors right now. So why not bring it to geospatial, right? I've got the vector for this location aggregated, and this is the similarity map. I'm comparing the West Coast with the East Coast, and I can move around with this. And the comparison and inference times are super, super quick. So I can go to literally any place in the world and I can compare this location with all these tiles here. So these are H3 tiles, and another beautiful, beautiful concept in geospatial. And we've got Isaac to thank for it. And so suppose I wanted to go to, let's go to Spain, right? What if I wanted to compare New York, San Francisco with the rainfall patterns in Spain? Let's see if it is similar or not. And yeah, surprisingly, it is similar for some reason. Maybe who have visited Spain might have noticed that the rainfall patterns might be similar in San Francisco and Spain. I haven't, but this is what I get from the app. So this is not just restricted to precipitation. It can be related to any of the parameters. And what this involves is computations at a scale which Fuse brings you. From ideation to these computations at a scale. This data is coming straight from the Google Earth Engine catalog. It's terabytes of data, and you can just load it so quickly. All these computations are happening as we talk, as we speak. It's not at all pre-computed. So I just love the speed that it's giving me, and the scale of data that I can work with. It's the whole world. The whole world is my canvas right now, and you know, uh, why Fused? I mean, I like how easy the AWS interface is. Said no one ever, right? So we as data scientists don't want to get involved into all the mess that all the mess of DevOps and engineering. We just want to do science and analytics as soon as we log into our systems. So yeah, this is the Google Colab level revolution for everyone in GIS. And yeah, this is Twin City for you, which I'm sure anyone who's interested in can reach out to me. We can talk more about it, about what business applications that we can have, and how did I build it. Let me just dive more into that. So I'm getting the data from Google Earth Engine catalog. It's I'm trying to aggregate the data into these hexagons, these H3 hexagons. I'm binning the data into these hexagons to make it easier for comparison, loading it all into DuckDB, and then running a cosine similarity among all these hexagons. As simple as that. It really does sound very simple, but uh, doing it at a scale is a challenge. But that's what I've achieved with Fuse in probably a day or two, and even created a prototype for it. So that's pretty neat. So yeah, I do calculate the similarity search for similarity between the two hexagons to find the similarity between two hexagons. Uh, Load it into the app builder, and we have the app right there. So that's about it for the demo, and let's connect with Twin City. Thanks.
Thanks, Milind. As I was watching that, I was kind of thinking about the potential of like looking at historical weather data to find like what, if you're familiar with something where you grew up, where is that similar weather patterns now, or even thinking about climate projections in the future, where do you want to be in 10 or 20 years if you like that type of weather patterns. So thanks for that presentation. We're going to move on to our final presentation for today, and that is